hello everyone. Sorry for the delay. I think everyone needed this break, but then it started to be a bit too long. So we hope the fast forward is going to be okay. We have some logistical issues. So first of all, thank you for coming. We were very stressed by the conference organization. You've been sending us emails. We've tried to be reactive. And so we were feeling like maybe we were not controlling everything. But I had a lot of feedback today that were very positive. So I'm cheered up a little bit, and we can go ahead for the full week. So we welcome you today in Reims, which is a city in France. Everyone figured out this thing. And we host you at the conference center. This is not where we work every day, obviously. But this is a very nice congress center, and we're very happy to welcome you here. From center downstairs that she was managing all the badge distribution. And then we were not alone on this, so we are the researchers of the lab, but we also had some extra people from the university that helped us a lot. Some are here today. There was Arnaud Renard this morning as well, and Charlotte, who is helping this week. And also some more people from the general university organization. Some are the technicians of the university, some are in the accounting department of the university, some are the administrative department, and some staff from the that are dedicated to conferencing in our university. So they all helped us, and we know that we've been running under delay for some things, but I can assure you that everyone is dedicated to the conference. And also, we really had a very strong support for the people from the Congress Center that helped us setting up this conference. We've been in touch with them since 2018, and they've been updating us with the new facilities and the new things that were happening in the Congress Center. And so I would like you to applaud them and thank you for their help. So also, you've met them around. We have 22 volunteers that help us with the conference. Some are from Reims, but many of them are not from Reims at all. Some are from somewhere else in France. Some are somewhere from Europe and other countries. So I asked them to send me pictures, but I haven't received them yet, all of them. So maybe they can stand up so that you can recognize them in the audience. So all the volunteers, if you can stand up, please. So yeah, they've been already really helpful until now. So now let me present you the program chairs of the conference 2022. There are Min Kim from KAIS Korea and Raphaël Chen from l'IRIS in Lyon in France. So they will be giving a talk afterwards, so I will let them introduce themselves. So, but they've done a lot of work as well. And then we have tutorial chairs, Stéphanie Amann, who is here, and Gustavo Pato from Girona University. So Stéphanie is from Grenoble. The state-of-the-art chairs, Daniel Menvo from the University of Poitiers, and Giuseppe Patane from the IMATI in Genova. And I haven't met him, but I know he's somewhere around as well. The short paper chairs, they were David van der Heg, from Toulouse, and Nuria Pelechano is around, so you can speak to her if you want. She's from Barcelona. The poster chairs, they are Basile Sauvage from Strasbourg, and he's here as well. He's sitting there, I've seen him earlier. and Yasminka Azik, who couldn't come today, but they've been working together. The educational chairs, Jean-Jacques Bourdin, who should be here somewhere, but okay, he's arrived now. And Eric Paquette, who's come from Montreal for this conference, from quite far. And the industrial chairs, there's Rémi Cozo and Oliver Groh from Intel, who has been working on the industrial program. The doctoral consortium are chairs by Julie Dean and Noska Smith, who are here as well. And the diversity chair are Noura Faraj and Diana Aureliano. So it's a new thing for Eurographics to have chairs of diversity, but we've been having diversity panels for some years now, so it became interesting to have also people that would do the work for that. And they are around as well, both of them. Just to come back, the diversity session is also supported by Disney Research. We have 4 invited speakers. So on Tuesday, you will see the talk of Sylvain Paris, who is on his way. He's coming directly from Boston, so he's almost here. On Wednesday, there's Jan Kautz from NVIDIA, who will give his talk online, but in this amphitheater. On Thursday, there's Ayelet Tal from Techno University, who is also going to be here. And Friday is going to be Mathieu Desbrun, who was at Caltech and is now settling down at the INRIA in France. We are very grateful to all our partners that supported the conference. We really couldn't have done it without their help because we had many expenses, and it's really great that they all help us. So we have local help from the university, the Reims city, the region, a partner as well from the CEA, and of course we have the full support of the Eurographics Association. And then we had other sponsors, industrial sponsors that help us, and some of them have a booth here, and you can go and meet them. So this is the map. I guess everyone arrived here, so you know where we are in the map, but I wanted to show it a little bit more. So you can see that the conference center is very near the train station, is in the border of Canal, and most of the hotels are the red dots that you can see here, and they are all in the city center. Many of them are in the city centers. Everything, if you choose a hotel that is not so far from the conference center, can be done, is at walking distance. You can go and run if you want along the canal. There's a path, a pedestrian path, so I hope some of you will take the chance to go there. And then there's the park as well. If you want to have a break during the conference time, you can go for a walk in the park that goes up to an arch, which we call the Porte de Mars, and which is quite nice and well known in Reims as well. So here is the main theater of the conference. Some of you that were here today for the tutorial, you already experienced it, and there's going to be some paper session here. All the common session will be in this theater, so we will have also the invited speakers here. And then there are 4 other conference rooms. So they are on the same floor on the side of the conference center, and there we will have other sessions, so paper session, tutorials, short papers, panels, and etc. Star papers that will take place there. And people that were here today, we had lunch at the Millésime. So the Millésime is downstairs from this amphitheater. So we've tried to have very short lunches so that we could make the most of the day with the sessions. The meal is set with a starter, a main dish, and a dessert, and everything is served into a bowl. And so you can just take your bowl and then go to the table and enjoy your lunch. And someone will bring the main dish at the table for you that is going to be warm. So it's an experience. We had it for the first time at lunchtime, and many people enjoyed it. So everyone that are here and haven't had lunch here, I hope you will enjoy it tomorrow as well. We've tried to take into account all the diet restrictions that people sent us. If you have any issue, if you feel that something is wrong, you please come and talk to me or other organizers, and we will try to arrange so that everyone can eat as they feel that they should eat. So specifically, help us if you have any type of allergy or intolerance, and help us to help you with that. So the program was online for quite a while. We tried to fill the sessions one after the other as soon as we had the order of the sessions. So they are ordered to be a first column in the amphitheater, and then you have from room 1 to room 4. And you also have the detailed program in the red part down below on this slide, which are also below on the website, and you can follow the order of the papers in the sessions. So we have a typical Eurographics program. We have the paper sessions. We have the short paper session. We have the state-of-the-art session. And then we also have the education sessions that will start on Wednesday. There will be education session on Wednesday morning and a last one on Friday. There will be also an industrial panel on Tuesday and Thursday. There's going to be a diversity panel on Wednesday afternoon. And there's the Wicked workshop that is going to take place on Thursday. You will also see that we've tried to book 1 hour for posters. So the presenters of posters, please be next to your poster in the afternoon for the 1 hour dedicated to poster. They are the same place as the coffee breaks, so that everyone can have a break, but go and do science and speak to the authors of the posters. We also have an area for industrial demonstrations. So some people have planned to show a demonstration to you. There will be an opening, a specific time that is dedicated to this tomorrow evening at 5. So there's 1 hour dedicated to this, so you can go there, and there's no other session in parallel. Otherwise, you can attend this booth if someone is there during the breaks, the coffee breaks, for instance. There are some mention of Reims city tour in the program. We haven't planned anything in particular. It was just time that we thought you should dedicate it to go and visit the city. There's going to be a link that we will send you maybe for some experience, champagne experience, but that's more or less what we've planned. So please go and use this time to stroll around the city. The main events are tonight at 7:30. We will meet at the City Hall, and Wednesday evening we will have the special event. The other events that are on Tuesday and Thursday are for restricted committee. So you've noticed that we are under a hybrid mode. That means that everything is streamed. Everything is set to be looked also for remote participants. It was complicated for us to set up this hybrid mode, and we've been asking the speakers a lot to prepare in advance some videos, to prepare in advance some presentations so that we can do it. No one can plug their computer. We are forced to use with the OBS system that is doing the live transmission, so that we are forced to have that on one main computer. And I would like to thank all the authors, all the speakers that played the game, and it was really nice that we could set it up and have this hybrid mode. So thank you very much. I want to applaud you. So we have the collocated Wikid workshop, which will take place on Thursday. The program was set after we opened the registration for the conference. So some of you didn't register at the same time to the Wikid workshop. It is still time to register. There's still some space in the room, obviously, and so don't hesitate to go and visit the page and have this extra registration for Thursday. It will help also the workshop to be alive, and there's going to be very interesting. There are going to be very interesting presentations. So don't hesitate to look at the program and register if you want to attend this workshop. We've tried to get inspired by what Werner did last year. It was easier because he was online, so he could set it up online, but maybe we want to try it. So we're going to try to have the best fast forward prize from the public, the best poster prize from the public, and the best presentation prize from the public. So there's at least 2 links that we've prepared for the best fast forward and the best poster. So check which one you like, and then once you receive the link, you will be able to vote for those. And we will be giving the results at the closing ceremony. So for the city tour, there are many monuments in Reims. Reims is a historical city for France. This is the city where all kings were crowned. Not all, but most of the kings were crowned, and you can know more about it if you're visiting these monuments. So I would advise you to go and visit the Saint-Remy Abbey and the cathedral as well of Reims. And do as much as champagne tour as you can do, because the cellars are absolutely fantastic. You can't imagine we are actually above some gallery, and the champagne wine is spread everywhere under our feet. So it's massive, and you will really enjoy it. There are also the Tau Palace, which is next to the cathedral, but you will have a chance to visit it if you participate to the special event on Wednesday evening. So tonight we will go to the City Hall of Reims. So you should have on your ticket there's the address. We will try to have groups of people to go there. The organizers, we came by car this morning, so I'm not sure we will be able to bring you there. I hope that there's going to be some forming groups to go there. But it's not far. You can see on the map. From here, it's a 15-minute walk, so you can reach there very easily. So it's going to be a welcome reception, so it's not going to be a dinner. You're going to have some small bites and drinks, and a welcome from the city representative and the president of our university. On Wednesday, there's a woman lunch, and it's an exclusive event for women. We're sorry for that, but we need to identify ourselves because we're still much underrepresented than men in this conference. And it's going to be at the Demeure des Comtes de Champagne, which is close to the Hôtel de Ville, to the City Hall. And it's also accessible at a walking distance. And this event is sponsored by Disney Research and the Tétinger Champagne House. And then on Wednesday evening, there's a special event at the Palais du Tau. So the Palais du Tau touches the cathedral. So if you find the cathedral, then you find the Palais du Tau. It's very easy to find. So we're going to have a dinner within the museum, which is, the Palais du Taux is now a museum. And they welcome us from 6:30. On Wednesday, there's going to also be the General Assembly of the Eurographics Association. So those who are not members and do not want to follow this General Assembly, you can start to go and visit the Palais du Taux from 6:30. And others, we will be able to join right after the General Assembly and visit the museum. We can stroll inside the museum, just us. It's a private reservation just for us. And then we will have a seated dinner. You have on your tickets as well, you have a ticket with the login and password for the Wi-Fi. Those who have EduRoam, you can directly use EduRoam for the Wi-Fi. The Wi-Fi is installed only in the used space for the conference. So you have it only in the rooms and the areas where we have the posters. You won't be able to have the Wi-Fi elsewhere. So some people told me this morning, and yes, it is. If you are at the entrance, you don't have the Wi-Fi and etc. So it's only located in the main places. This is the numbers I got. We have above 300 participants on site. Some of them actually are registered on site but attend remotely. So I think we're more around 300 present at the conference. These are the numbers from Thursday. I compiled them Thursday for the presentation, so they might have moved a little. I know there have been some registration. And I'm sorry to say, but if you hear French in the corridors, this is normal. We're quite a big number of French representatives. It's 149 that I have on this on this diagram. And then there's Germany, who is following. It's not so far actually, Germany from Reims. So I guess it helped. But there's also a big graphics community, so 35, and then Austria, USA, Switzerland, and Israel, and many others. So we're very glad to have so many countries that publish and attend and speak at the conference. So yeah, maybe I should say there's almost 100 remote participants as well that are following the conference from remotely. So thank you very much. I hope I didn't forget anything, but I think I spoke already for quite a bit. So if you need anything, please come to us, and otherwise enjoy the conference. Thank you. So now there's Jean-Michel Dischler, the president of Eurographics.
The association. So this year I'm really particularly pleased to welcome you in person here in Reims in France. This year because after 2 years in which the conference could only take place online, it's really a great pleasure and honor for me to see you in live and not only behind a screen at home or in your living room. So first of all, of course, I would like to thank the organizers for their really great work, because as Céline told, it was certainly really not easy to organize this conference, because it's for the first time, it's a hybrid conference. So face-to-face and online. And this is really the first time. So this allows us here, the association, to welcome you not only online, on screen, but also really here in front of you. And organizing this hybrid format has surely been really a great challenge. And so I would like to warmly congratulate the organizers for having mastered this, and really quite well as far as I can see here. So thanks to the tremendous efforts thanks to your tremendous efforts, we can enjoy being here today in this auditorium, and also for many other peoples, 100, you said, behind the screens, and really for that we would like to thank you. So let me just say, it would not take a long time, just a few words about the organization. I would like to emphasize that the association, in spite of these really great difficulties of the past 2 years, has managed not only to maintain its 2 flagship conferences, which are this conference, Eurographics, but also Euroviz, at a really high level of quality. And of course, the same applies for all other workshops and symposia that the association is organizing. And really, it has also been able, in addition, to adapt and to evolve. And this is thanks to the support of its individual and institutional members. The association exists because it has members and volunteers. And these members are the researchers and research institutions in the field of computer graphics. And therefore, I would like to appeal to you to continue to support Eurographics as you have done so far. Eurographics is not limited to these highly visible international conferences. It also serves to promote our discipline to our national decision holders and to make it visible, showing presence, showing that computer graphics exists as a scientific discipline is important, especially in these times. And in addition, Eurographics events also serve as a career booster precisely for younger researchers and for the future, and for whom a publication at one of these conferences that is organized by the association can have sometimes really an important impact on their careers. And it makes careers visible through its prestigious awards that we will see right now given by Roberto, which will be the next speaker, I guess, and which recognizes exceptional talents. Through its digital bookstores and publications, the organization makes also scientific material available and accessible to all. And all these services are only possible thanks to the support of its members and volunteers. And in order to maintain these services in future, I really ask you to renew your membership at the end of the year and to encourage colleagues who are not yet members to become members of the association, to show that they belong to this computer graphics community. And by the way, I would also like to invite you, at least all members, to participate to the General Assembly that will take place on Wednesday. It's important. It shows also that when you are a member, you are an actor. You can help in taking decisions. So that's all I wanted to say for the association. So thank you again for your participation. Thank you to the organizers. Thank you to the authors. Thank you to the members of all these program committees. Thank you to all participants here on site remotely. And I hope, and no, I do not hope, I'm sure we will enjoy this 2022 edition of the Eurographics conference. Thank you very much. Thank you so much.
So now we're going to have a presentation from the... do you want to go first? Oh, I was thinking the paper chairs, maybe? Yeah. Sorry.
So thank you, Céline, for the introduction. It is our pleasure to present you this unforgettable experience of chairing the full papers program. We are very proud of the exciting programs that we managed to set up during all this year, thanks to your numerous submissions and that you will experience during all that week. That year, we had 119 full paper submissions, which is rather similar to last year with a small decrease. And among those papers, 40 papers were accepted, which gives a 33.61% acceptance rate, which is lower than last year. However, this year we had 11 papers who needed major revisions and who could be submitted as a in a fast-track mode to CGF. And additionally, there will be 9 CGF papers that will be presented within the conference, within the full papers program. So we had submissions from all over the world, and more specifically, the countries with the highest numbers of submissions were China, France, United States, and Germany. And if you look at the accepted papers, they cover Europe, China, United States, but also Israel, Switzerland, and United Kingdom. Most papers usually have between 2 and 5 participants with a targeted contribution that should be replicable by interested users. And if you look at the topics that were preferential that year among the submissions, you can see that there was mainly a lot of papers on animation, followed by papers on methods and applications and imaging and video. There was already, that trend was already present last year. And if you look more precisely, you can see that it's very difficult to have a paper in modeling, but also in animation. It's quite more difficult than in the other topics.
So let me try to explain to you the reviewing process here. So first of all, after the deadline, so once the people submit their papers, so we began the bidding, which is done by IPC members. And then based on the bidding grade and also the expertise of the ICP members, we start sorting. So sorting is done by advisory board, and then once we have, so we actually have a full list of the IPC members assigned to some certain number of papers. So, and for the reviewing process, we have, so our goal is to set at least 5 papers for each submission. So we have a primary and a secondary reviewer. It's like a C-graph. So then we have some primary reviewers to assign the 2 tertiary reviewers, and also secondary reviewer also assigned 1 tertiary reviewer. So in total, we're going to have 5 reviewers. And I'm very proud to say that all the submission in this year, we have at least 5 reviews. So, and then once we finish the whole review, so we begin with the rebuttal process, and the rebuttal process is basically allow the authors to address some certain error in the review. And then after this, so we begin with the tertiary discussions using BBS, so which involved with the IPC members and also tertiary reviewers too. And the last stage is so we have a virtual IPC meeting, and then IPC members actually went through the submission and the review and also rebuttal and the discussion, etc. And then finally they end up with choosing 40 full papers this year. Right. So actually, I would like to thank many people here. So first of all, let me begin with our advisory board. So Theodore and Rachel and Sylvain, Ivan, and Mikhail. So they helped for paper sorting, and also I would like to thank their patience in replying our emails even during weekend. Also, here we have a very big list. It's 65 IPC members in total. And I hope you can read all the names over here. So first of all, they are involved in the reviewing process, and also they also wrote review. And then finally, they invite some expert reviewers who are relevant to the submission. And when we invite IPC members, we follow the rule. It's no more than 3 consecutive years of IPC participations. Right? And then here we have an even bigger list. It's the name of tertiary reviewers is 299, is virtually 300 people are working on this review. You might get surprised, actually we have 600 review. Actually, it's even more than 600, and to get the full paper list. And then, without this help, it wouldn't be possible to have a wonderful full paper program this year. Right.
Now, we have reached the opening of the conference, and it's time to thank the session chairs. We will ensure that the sessions run smoothly throughout the week. And the chairing will be done on site. But it will require many online communication with remote speakers that could not come due to travel restrictions. So it is a technical challenge that we will have to overcome, and we are deeply, deeply thankful to the session chairs for ensuring the success of the conference. We also want to thank the CGF editors-in-chief, the current one, but also the former ones, and namely Elvig, Benesh, and Pierre, for the publication of the full papers in a special series of Computer Graphics Forum. And we also want to thank them for providing us input to select a few CGF papers that could be presented at this conference to complete the program. And now we want, last but not least, we want to warmly thank Michael and Stephanie Benke for their invaluable support in the use of the online submission system, SRM, and also for preparing the final proceedings. We are not finished.
So actually, there's a very last one thing I would like to share with you guys. So, well, we actually met, with each other online, of course, almost for 1 year, in order to prepare the full program. So I think we are exchanging so many emails and day and night. And also, I'm in Korea, the Raphael in France, and then we are in different time zones. We actually work as like one team. It's 24 hours and 7 days. It's a great, great pleasure to work together. And also, I would like to thank the EG General Chair, Celine. It's a really, really great job. Without her, we wouldn't make a very good program like today. And also, we would like to thank the EG executive members and also all the people who made this event possible. And also, the last thing, I would like to thank to the technical team. So, as Celine mentioned before, it's so difficult to manage hybrid systems, right? Not only on-site, but also online presentation and also communication. So we would like to thank again, for the technical team. And then, so this is the very last statement I would like to say. So it's our great pleasure to be a technical paper chair with Raphael and me together. And I hope you enjoyed the full paper program this week.
Now we let the place to Roberto Scopigno.
Evening to everybody. I will have to present the Eurographics Award 2022 edition. Okay. So just a brief notes on the history of this award. We started to give awards in 2004, so it's still some years, and the first edition was in the occasion of the 25th anniversary of our association. The goal of the program is recognize, highlight, and promote computer graphics research in Europe. And so we try to find individuals who have significantly advanced the field of computer graphics. We usually give 3 technical awards, a Young Researcher Award, Outstanding Technical Contribution Award, Distinguished Career Award. This one is given every second year, plus the EG PhD Awards. There's an error in the slides, but nobody has noticed. The EG PhD Awards was chaired by Niloy Mitra, and since this year it's chaired by Pierre Alietz. Sorry for the typo in the slides. This year we have one Distinguished Career Award. It's one of the years in which we have complete set of prizes. One Outstanding, 2 Young Researcher, and 3D PhD Awards. I would like to thank the committees for their hard work. We discussed this morning in the Executive Committee meeting the possibility of disclosing the names of the people which are behind this selection, these decisions, because it's not just myself and Pierre. We have 2 committees who evaluate people and take the final decision, and we will publish the name also of these people since next year in order to give complete transparency on the process. So let me start the PhD awards, Pierre.
Hi, everyone. So the Eurographics PhD Awards is the goal is to recognize the excellent thesis work in Europe, and it's also the opportunity to offer them the opportunity to publish the state-of-the-art section of the thesis as a state-of-the-art report in the Computer Graphics Forum journal. So I wanted to say that I formed a small committee that is kept secret. So we were 6 people, and we really enjoyed reading one of the best thesis work in Europe. So I think it's really great pleasure to evaluate. It's not also easy because we had to make a selection. Okay, so the winners are, there is no particular order, okay, it's just 3 winners. First one is Mark Haberman for his strong technical contribution to real-time capture and synthesis of human performance. Is Mark in the room? Okay, Mark. Mark did his PhD at MPI Saarbrücken, advised by Christian Theobald. You need to go on to step up on the stage. I don't know if there is someone taking a photo. Yes, if there is one. Let's do that. Want to say 2 words?
Well, I haven't prepared a speech, but thank you very much. It's a real honor here to be here today, and I hope you enjoy the conference. I'm also looking forward to the talks. Thank you.
Second PhD award is given to Ylva Ferstel for her pioneering new methods for generating virtual human gestures from speech. And Ylva is not attending the conference. She's remote, so she sent us a video. And Ylva did her PhD at the Trinity College Dublin, advised by Rachel McDonald. To click on that video. Should I? On the video, yeah.
Hi, I'm Ylva Ferstel, and I completed my PhD at Trinity College Dublin in Ireland under the supervision of Dr. Rachel McDonald. And I first joined Rachel's lab for an Erasmus internship and then stayed for a PhD in multimodal conversational behavior synthesis for avatars. And right away in that field, I gravitated towards the area of co-verbal gesture generation from speech. So in a nutshell, I was developing machine learning models that take as input some speech audio recordings and then produce as output the corresponding upper body movements for a virtual character. And this allows us to make virtual characters more engaging and lifelike without costly and unscalable hand animation. So I'm very honored to receive the Eurographics Thesis Award and want to thank the committee for taking the time to assess my work. And then my greatest thanks goes, of course, to my supervisor, Dr. Rachel McDonald, for all the opportunities that she gave me and for supporting me and encouraging me throughout. I also want to thank Dr. Michael Neff, who became a sort of secondary supervisor and was always very generous with his time and resources. So thanks to you all.
Third PhD award goes to Julien Philippe. Julien for his pioneering contributions to multi-view image editing and rendering, enabling casually captured scenes to be rendered with content alterations, such as object removal, relighting, or scene composition. And Julien did his PhD at INRIA, advised by George Dretakis. I think Julien is in the room. Of course not.
Yeah, thank you very much. I'm really honored by this, and I want to thank, obviously, George, who's here in the room. And yeah, I guess that's it. And I wear the same sweatshirt for consistency.
We are now to the technical awards. The first, First winner of the Young Researcher Awards is Angela Day, in recognition of her outstanding contribution to computer graphics with new approaches to reconstruct semantically understand and synthesize models of the real world. Angela Day's work is significantly advancing a thriving field of research at the intersection of computer graphics, computer vision, and artificial intelligence. Her work contributes to better ways to reconstruct, semantically understand, and synthesize models of the real world, which is of great relevance to computer graphics and augmented and virtual reality, but also for the design of intelligent systems that need to understand the world they interact with. The work of Angela Days is published in the top-tier conferences and journals in computer graphics and computer vision and has been widely cited. Eurographics is pleased to recognize Angela Day with the 2022 Young Researcher Award. Angela? Just the diploma, but you also have heavy stuff for you. Give me the diploma and this one, the lower one.
Okay. Thanks for the great honor to have awarded me this. So I wanted to mention, of course, actually my first conference experience was in Eurographics in 2014. So thanks to Eurographics for helping me get my start into looking into 3D reconstruction, how to learn to reconstruct semantically informed 3D models of real-world environments from just commodity sensor kind of inputs. So thanks for the awesome experience here first in terms of computer graphics and learning about the 3D reconstructions. I also wanted to thank my advisor, Pat Hanrahan, as well as some key mentors, Tom von Kauser, Leo Giebes, Matthias Niesner, and also Rüdiger Westermann, as well as the amazing students in my lab now at TU Munich. So thanks.
Second Young Researcher Award is Jürgen Bernhard. Jürgen Bernhard receives the Eurographics Young Researcher Award 2022. Jürgen obtained his PhD in computer science from Technical University of Darmstadt. He is now an assistant professor at the University of Zurich, where he leads the Interactive Visual Data Analytics group. Jürgen has already made groundbreaking and impactful research on a range of fundamental aspects such as the characterization, design, and evaluation of visual interactive interfaces that combine the strengths of both humans and algorithms. His novel work on interactive machine learning and data science application has paved the way for new exciting research and applications. For his outstanding and multifaceted contribution to the visualization and visual analytics community, Eurographics is pleased to recognize Jürgen Bernhard with the Eurographics Young Researcher Award 2022. Unfortunately, this year we have two persons. Jürgen is the first one who got ill in the last few days. So they had planned to be here. They spent money in planes and registration, and at the end, it was impossible for them to attend. So with great they were not so happy of that because obviously it's a nice moment to be there.
Dear colleagues and friends, thank you so much. I'm incredibly happy about this award. Unfortunately, I got sick over the weekend, so that I did have to cancel my trip to Raw. I'm incredibly sorry that I can't experience this moment together.
Stop it. You start it again. Just can we try to start again, or?
It's just so sad. Nevertheless, I would use my short speaking time to sort of get in touch with a few people who brought me that far. First of all, I would like to thank Dieter Fellner and Tobias Schreck for our incredible works on visual search and data exploration techniques, especially for digital libraries in those days. Thanks for collaborating with me for more than 10 years now. I want to thank Jörn Kohlhammer for our applied collaborative research, especially in the sense of visual computing in medicine and healthcare. Thanks for collaborating with me with over 50 research papers right now. Wow. I want to thank Heidi Schumann and Cedric for our joint projects in visual analytics on time series data. You have always been true mentors for me. Thank you so much. Dear Michael Sedelmeier and Matthias Zeppelzauer, thanks for our achievements in interactive visual data labeling methods. I'm sure that also in future we will be able to sort of shape the landscape in data labeling, solve problems of real-world users, and make methodological contributions to interactive machine learning. Finally, I would like to thank Tamara Mansner for our collaborative design studies and contributions on methodology and visualization design. It was just fantastic to be together with you at the University of British Columbia in Vancouver. Greetings to all of you from the University of Zurich at the Lake Zurich. Enjoy your work, and once again, I'm so sorry that I can't be with you. Thank you very, very much. Have a nice time. Bye.
Big applause for this colleague who is probably looking at us from his house now. Could you switch? Okay. So we are now at the Outstanding Technical Contribution Award, and the winner is Diego Gutiérrez. Diego Gutiérrez is a professor at the Universidad de Zaragoza in Spain, where he founded and leads the Graphics and Imaging Lab. His main areas of interest include global illumination, physically based simulation of light transport, virtual reality, computational imaging, and perception in computer graphics. Diego has made outstanding contribution to several research areas of core relevance to computer graphics. His work is distinguished by his deep interest in pushing the boundaries in simulating light transport, for example, by including the time dimension or targeting novel display technology, and his quest to understand how state-of-the-art computer graphics techniques relate to human perception. In addition to this technical contribution, Diego is highly respected for his success in fostering thriving research communities. This includes not only his leadership of the Graphics and Imaging Lab at the University of Zaragoza, but also its service to the broader community with milestone contribution to journals and conference management. In summary, Diego is a role model in the field by showing a breadth of research topics while maintaining a deep technical focus and making pioneering contribution to many areas, and by inspiring young researchers to continue pushing forward the state-of-the-art in computer graphics. Eurographics is pleased to recognize Diego Gutiérrez with the 2022 Outstanding Technical Contribution Award. And as you can imagine, this is the second person who got here and sent us a video to thank and to say hello to the community who gave him the award. This should start. Perfect.
Well, thank you very much. I'm honored to receive this award from Eurographics. Unfortunately, I cannot be there today because I hurt my back and I cannot travel. So video it is. Of course, any award, even individual awards, are never due to the effort of one single person. So I would like to thank, starting with my PhD supervisor, Francisco Cerón, who introduced me to graphics as an undergrad. Of course, all my colleagues, co-authors, and students. And I would like to highlight a few names that helped me early in my career, like Holly Rushmeyer. The first time that I worked in graphics, I was trying to reproduce Holly's tone reproduction papers. And this was before email, that's how old I am. So there was no email, and I, of course, had doubts about the papers. So I would write her handwrite letters with stamps and everything, with my doubts, my concerns about the paper, send them to her, and just wait. And a few weeks later, she would actually answer me by letter. And she was very nice. And she would actually say, why don't you use email the next time? But I had no email in my university, so I would write her again. And yeah, thinking back in those times, I really appreciate that Holly Rushmeyer took the time to answer me by letter. Also, Alan Chalmers and Eric Reinhardt, they encouraged me also early on in my career to pursue this career. They saw a presentation that I made in 2004 and said, hey, maybe you can be an academic at some point. And I had never thought about it at that point. And also Henrik Van Jensen and Ramesh Raskar, who very kindly allowed me to visit them and work with them in San Diego and at MIT, and from whom I learned a lot of things. Of course, I want to thank all the reviewers that rejected all our earlier papers. Yeah, maybe not all of them, not all of the reviewers, but you learn a lot by rejection, right? So this was not an easy ride. To build a successful group was not easy. It took a lot of rejections, but we learned from them. We learned how to write, how to do better research. So thank you, reviewers, for your time and your rejections. Also, thank you, Eurographics, of course, for this award, for picking me out. There's a bunch of people that deserve this at least as much as I do. So thank you for choosing me. And of course, thank you to my family and my friends for basically always being there. But the one thing that I'm the most proud of through my career is having built the graphics and imaging lab in Zaragoza. As I said, this has not been easy. This has required the effort of many people, lab members, past and present. So all of you guys, this award is mine as much as it's yours. Thank you very much. And to all of you in the audience, again, thank you very much.
I also hope that Diego is looking to the presentation, and so it's enjoying it with us. And we have nearly finished. We've just missed the last one, the Distinguished Career Award. I'm very pleased also because this year I can present this award in her native country, since we are in France. The awardee is Marie-Paule Cany. Marie-Paule Cany don't think that organizing the Eurographic conference in your country is sufficient to get the award, obviously. But in any case, it's a pleasure. At least she has a lot of colleagues in the room, as we heard before. Marie-Paule Cany is a professor of computer science at the École Polytechnique, where she leads the Modeling, Simulation and Learning Group. Her research interests include shape modeling and computer animation, where she has made multiple pioneering contributions. From implicit surfaces to the animation of deformable bodies, Marie-Paule has proposed impactful models for representing shape and motion. She introduced novel ideas for modeling and animation of hair and garments, as well as natural phenomena, from lava flows to ocean waves to clouds. She is one of the pioneers of sketch-based modeling applied to a variety of shapes, such as garments, trees, and developable surfaces. The contribution of Marie-Paule to research, management, and community building are also outstanding. She served on multiple leading roles in the computer graphics community. She was the president of Eurographic Association and was the director at large in the executive committee of ACM SIGGRAPH. Cany served as a technical paper chair of SIGGRAPH 2017 and of many Eurographics events. Marie-Paule has also received several prestigious awards, including the Eurographics Outstanding Technical Contribution Award in 2011. She was elected for the Accademia Europea in 2013, for the HCM SIGGRAPH Academy in 2019, and for the French Academy of Science in 2020. Our mind is boundless in its ability to visualize and design. Her work has created conduits for communicated visual ideas used by a generation of researchers and practitioners. Thus, her research has enabled collaboration between creators, scientists, and engineers, and significantly advanced the field of computer graphics. Eurographics is pleased to recognize Marie-Paule Cany with the 2022 Distinguished Career Award. Marie-Paule? This is for you. For you?
Yeah. Thank you very much. Thank you very much. So I'm so pleased to receive this, to be granted this recognition by the Eurographics Association, which has been so dear to me for many years. In fact, my first Eurographics conference was in Vienna 31 years ago. And since then, I was in this Eurographics community. I was already assistant professor in Paris. From Paris, I moved to Grenoble. And then 5 years ago, I moved back to Paris. So the people I would like to thank are, first of all, my family, and especially my 3 children, who was so supportive for all these years when I was working so hard on research. The second group of people I would like to thank I put some of the faces here, but of course I could not fit anybody, everybody. But the people who shared team with me, you know, in France it's very particular because we are not a professor alone with their student, but we are sharing teams, we are sharing projects, budget, and very often co-advising students. And all those people here on the right, starting with my PhD advisor, Claude Puech, on top. So we built team together. And we worked together for many years. We tried to get funding, we tried to set up projects, and these colleagues were so supportive. It's really thanks to them that I could do this career and manage to have those contributions. And there is a second group of colleagues who I would like to thank, is all of you who worked with me, who collaborated with me, who co-advised students with me. And here I have put a few of the faces of the colleagues who are the most relevant and inspiring to my career. Maybe some of them inspired me with the way they are taking research and supervising students. Others were really key helpers and collaborators at key moments of my career. And I'm particularly happy to have some of them who are still willing to work with me. And at this stage of my career, when I'm president of department and have so little time for research, I still have some colleagues who ask me to have colleagues, to share PhD students with them, to have some application for project with them, and this is so nice. And of course, most of my career was the work I did with my PhD student. And here it's the most enjoyable time I could have. We spent really great moments co-inventing many different stuff. In fact, I supervised 36 PhD students, plus master students, plus a few postdocs. So I decided not to put a long list of names, but rather to give some examples of the research we did together. And really, I hope that everybody here in the room will have such opportunity to work together, to co-invent things with colleagues, students with their advisors, and it's really what makes research for me. Thank you very much.
This closes the session. I want just to remember you something which is really important. You should help us. You should help us. It's really important to receive nomination of clever people, so don't be shy. Send us nomination for the next year event, both to me and to Pierre, in order to simplify our work. If we start from a good number of names nominated by colleagues, our work is easier and it's also much easier not to make errors. So thanks a lot, and remember to send us nominations.
So thank you, Roberto, thank you, Pierre, and congratulations to the awardees. We're running late, so I'm going to ask all the fast forward to be ready to jump on the stage when it's their moment. And we're going to start right now the fast forward, and right after the fast forward, we're going to go to the City Hall where we are expected at 7:30. Thank you.
Hello everyone, in this work we present a fast ray tracing framework for skeleton-based implicit surfaces. We start with the dynamic sequence space accelerations and then iteratively fit low-degree polynomials to find fast and efficient ray surface intersections so that we are able to smoothly render these shapes and including complex microstructures. Our talk is tomorrow. I hope to see you there. Thank you.
We present DRESSY, a hardware-agnostic differentiable renderer with reactive shader packing and source rasterization. DRESSY can perform inverse rendering to optimize 3D geometry by 2D images. DRESSY can run on various devices, including a laptop and mobile. Our full-AD system design eliminated hardware dependency and obtains higher performance by separating DR algorithm and differentiable functions. Balkan API and automatic differentiation for DR are key factors. DRESSY is high performance. It is 2 times faster than previous methods. DRESSY is robust and accurate in mesh optimization. Complex shaders are also supported in forward and backward passes. Please come to our presentation.
The title of our paper is Real-Time Virtual Try-On from a Single Example Image to Deep Inverse Graphic and Learn Differentiable Renderer. The contribution of our paper are the following. We propose a self-supervised framework for learning an inverse graphic encoder for non-differentiable rendering engine. We applied this framework to the task of example-based virtual try-on for makeup and hair color, reaching state-of-the-art results in real time on mobile devices. To the right, you can see sample results generated by our method.
Program traces are animated values evaluated during program execution. We propose a compiler framework that automatically extracts program traces for pixel shader programs. Each trace can be viewed as a feature map that is used to augment learning tasks which traditionally takes RGB input. For example, denoise output shown below based on the noisy input shown above. Or reconstructing a complex shader shown below based on a simplified input shown above. Or predicting the output of a flocking simulation based on the one with coarser time steps.
I want to enlarge the lighthouse in this photo, but zooming in and cropping would cut out the foreground ridge, an important compositional element. Using Zoom Shop, we can enlarge the lighthouse while keeping the ridge in place. In Zoom Shop, users can select different depth regions and adjust their scales independently. Zoom Shop uses a nonlinear camera model and a depth-aware warp to maintain important structures. We can adjust object scale, foreshortening, and positions to edit photographic composition. Come to our talk to learn more.
Everyone, it's my honor to introduce our work. In our work, we design a future contrast masking loss and a depth mu law to make it possible for self-supervised tone mapping. This figure shows our whole pipeline. Here we show the visualization of the future contrast masking. The input is the future map from VGG19. We can see after processing, small contrast will be promoted and more details appears. The testing results also show superiority of our methods than others.
We present a new formalism for modeling terrains using gradients. A terrain can be easily authored by combining a guiding gradient field and hard altitude constraints. This gives rise to a wide range of authoring tools that allow the creation of canyons, cliffs, mountain ranges, and can be used seamlessly in a standard copy and paste formalism. It is even possible to author a mountain that looks like the EG logo in a few user strokes. If you want to know more, come to our talk on Tuesday at 11.
Discrete Chebyshev nets are quad meshes with all edges of equal length. They are widely used in many fields.
How can I get such meshes?
Discrete Chebyshev nets can be generated by triangle meshes.
Then how can I edit a discrete Chebyshev net interactively? Can I deform the origin triangle mesh and regenerate a new one?
In such way the singularities may change a lot. Our article provides a way to deform discrete Chebyshev nets directly by constraining edge lengths and solving an optimization problem.
Reliable estimation of facial landmark positions is still an active research field, but the layouts in use remain purely empirical. Layouts generated by previous work lack similarity, and the question of what is a good layout remains open. We suggest to derive landmark layouts from blend shape models. In our approach, we assume that at least one good landmark is required for each blend shape. In addition, we formulate the entire problem as an integer optimization that can be solved in less than a second in harmonic models. Layouts computed by our method are similar, but more compact than empirical layouts.
How many different characters can you spot here? What if the answer is only one? State-of-the-art vision algorithms fail on animation as style changes drastically. We present a new style-adaptive representation learning algorithm using self-supervision. We leverage multi-object tracking to refine the base embeddings by a simple yet effective trick applicable to any video. Check out our work tomorrow at 4 p.m.
Do you want to do this cool bullet effect stuff for yourself? Well, setting up a camera array is just too expensive. Or you may just be too shy to ask someone to film around you. Now, just bring over your phone and a tripod. We have had a solution for you with this easy setup. Want to know how we model the human body with a single stationary camera? Come to our talk.
Inverse rendering techniques for facial appearance capture often make simplifying assumptions. First, the lighting is assumed to be distant, resulting in incorrect shadows. We instead accurately calibrate the 3D positions of the lights. Second, cross-polarized images are assumed to have no specular signal, which is not the case for a multi-view setup. We model polarization explicitly to improve rendering accuracy. Third, indirect light bounces are often ignored, leading to overshoot and diffuse albedos. We propose a texture space technique to alleviate this issue. Come to our talk to see how we improve facial appearance capture methods.
Are you tired of grabbing beers from the fridge yourself? Why not build a robot to perform that task? We did not build such a robot, but our research regarding monocular depth estimation architectures indicates that there is a trade-off between the estimate quality of transparent objects and high-level scene details between different neural network architectures, with potentially horrible consequences for your beer-serving robot. For more information, join our presentation on fitness of general-purpose monocular depth estimation architectures for transparent structures on the first session this Tuesday in room 3.
Perfect cell displacement mapping with COM-maps is great, but it takes too long to generate COM-maps. We introduce a quick GPO solution based on maximum min-maps. You can even compute COM-maps per frame up to 4K resolution. See you on Tuesday.
Global illumination rendering requires random light path samples. There are different techniques, for example, BRDF sampling and light source sampling, each with its own merits and drawbacks. Multiple important sampling combines sampling methods preserving their advantages. This paper addresses the problem of the optimal allocation of the sample budget to individual approaches. Should you be interested, come to the Rendering and Illumination short paper session tomorrow.
Volume rendering is essential to improve image quality, and with many light sources,
Tree-based light sampling is often used. However, it's sometimes hard to maintain. Then, with the stochastic light culling, we can bound the light range for each light without any bias and reject some lights for shading. In this research, we propose an efficient method to extend it to volume rendering. Our method doesn't require any acceleration structure. If you want to know the detail, please come to our talk. Thank you.
You know, real-time path tracing is becoming more and more a reality every day, but still high noise level of renders make it hard to rely on real-time ray tracing even with denoisers. That's why I'm planning to present a new screen space path guiding technique which decreases the variance of Monte Carlo estimator and also slightly improve the overall performance of computation. See you on Tuesday at 11 a.m.
.3D printing objects with overhangs often requires disposable support structures that are removed after fabrication. This removal step leaves scars where the supports meet the object, so they should touch in as few places as possible. We propose a new method for generating bridges and pillar supports inspired by example-based model synthesis. We take into account the object geometry to minimize the number of contact points, facilitating removal and cleanup. Contrary to standard synthesis algorithms, this is done without any backtracking or trial and error.
We present a way of generating textual descriptions as extension of scene layout synthesis. As example, we generate scenes of medieval fantasy villages. Automated descriptions could be used to make 3D content more accessible or allow generated actors to describe the world surrounding them. In our proof of concept system, first a scene relationship graph is derived from a hand-tuned graph grammar, then scene and text are produced using a combination of established techniques. Results are evaluated in a pilot user study.
Again, in this paper, we transparently render and slice skeleton-based implicit surfaces. For this, we propose a precise per primitive interval arithmetic so that we are able to transparently render and slice these surfaces robustly and efficiently. Our talk is tomorrow. I hope to see you there. Thank you.
Present materia. Starting from a single picture taken in the wild, it removes the shadows, recovers the surface normal, the material roughness, and the geometry to produce a high-resolution material. Now you have 20 seconds to produce 4 realistic materials to texture this 3D scene. Let's go in the wild. Thanks to 2 cascading neural networks, Materia allows to capture outdoor materials under natural lighting with any camera device and works at high resolution. Come see our talk Wednesday morning.
Have you ever wanted an Instagram full of motivational early morning sunrise shots, but you're too lazy to get out of bed that early? We present a method for single image relighting of outdoor scenes under arbitrary sun positions, including those early morning sunrises. We achieve this by utilizing an off-the-shelf depth estimator to get noisy scene geometry. Given a sun position, we sample across the depth image along rays towards the light source. This allows us to create a 3D feature volume which is passed into a 3D convnet to produce accurate shadow maps capable of long-range car shadows.
Imagine you would like to change the appearance on some of the objects in this image, like making the lamp up there look less glossy. Well, usually you would need to have some 3D definition of the scene and know how to manipulate the material in it, and usually you don't have a 3D scene. Well, good news, you don't need it anymore. Our method allows to take just a picture of an object, set an intuitive target appearance, and it will change the image for you. Our method is based on deep neural network trained with crowdsourced perceptual data. Yes, we have all of that. So I hope that all these buzzwords will convince to come to your talk.
You don't know which crowd simulation algorithm to use? Tired of checking which one works best? Stuck using a super complex algorithm just in case? Come to a presentation Wednesday morning. We systematically studied algorithms and parameter values in various contexts, and we mapped them to the best performing ones. The explanation of the evaluation and the context are included in the presentation. But wait, there's more. We will explain how characters can adapt their motion strategy to changes in the context, mid-simulation, and independently. Don't miss the chance to join us on Salon on Wednesday.
Generalizing motorcycle graphs to the volumetric setting, we present the motorcycle complex, a non-conforming partition of a volume into cuboidal blocks. The partition is constructed by extending walls, starting at singular edges and stopping only once they hit the boundary or another wall. Compared to conforming volume partitions like the base complex, it is coarser and thus faster to compute by orders of magnitude. On tetrahedral meshes, the motorcycle complex is a key ingredient for robust hex remeshing. Compared to previous state-of-the-art methods, it allows to generate much coarser meshes without defects.
We propose a simple yet effective method to perform surface remeshing with hard constraints. The challenges are twofold. First, continuous and discrete degrees of freedom. Second, non-differentiable constraints and objective functions.
How do you solve these problems?
We convert a constrained optimization problem into an unconstrained form and design a differential evolution algorithm to minimize it. We successfully apply our method to error-bounded Delaunay mesh simplification and error-bounded angle improvement. The time is up, let's talk about it next time.
We create volume meshes from point clouds and surfaces. Therefore, we fill up the volume with Voronoi cells, do a Lloyd relaxation, extract this edge graph, and in there we search for primitives which are constructed from a hexahedral by collapsing individual edges and are therefore at most hexahedral. And the final mesh consists of mostly hexahedral primitives, and the other ones are at most hexahedra but can be used as hexahedra, which is useful. See you.
Given a satellite top-down view image of your neighborhood, do you know the shape and composition of your roof? We present an automatic procedural modeling and deep learning-based approach to generate regularized building footprints and procedural roofs from a single satellite image. Our framework handles building footprint regularization, building decomposition, and roof ridge prediction altogether. Come to our procedural roof generation talk and see how the magic happens.
Human beings enjoy figurative art and can easily understand its content. Computers, on the other hand, have a much harder time understanding art, which would be surprising, as we consider them smart enough to drive cars. We present an approach for semantic segmentation of art paintings using domain adaptation between real photographs and a novel artistic dataset. Our approach learns the unique features of various art styles and combines this knowledge to achieve state-of-the-art results on seen and unseen art styles alike.
Are you interested in real-time texture space shading, but unsure which texture space representation to choose for your application? Join our talk about meshlets and how to shade them on Wednesday 5 p.m. and we'll show you our new texture space shading method. We combine efficient modern mesh shaders with a pre-computed texture space mapping to achieve a simple and flexible texture space shading method suitable for a variety of applications. We outperform previous work in terms of image quality, runtime performance, and temporal upsampling capabilities for a fixed number of fragment shader invocations. Join our talk on Wednesday for more details and discussion.
Subdivision schemes allow you to refine a mesh that fits well in memory into a detailed one that looks good on screen. Our algorithm applies loop subdivision extremely fast, enabling full recomputation at each frame in real time on the GPU. This allows unprecedented applications like visualization during mesh editing. We achieve this by reformulating the refinement rule over the mesh half-edges and enabling per half-edge evaluation in parallel. Want to know more? Come listen to our talk.
Just like marching cubes, dual marching cubes methods reconstruct surfaces from volumetric data which might come from CT or MRI. A major difference is that the result is quad only. However, in some cases we might get non-manifold edges. We show how these non-manifold edges can be removed in a simple post-processing step. It even works in complex scenarios with multiple incident non-manifold edges. Our CUDA implementation is available on GitHub and comes with a fancy GUI for you to test dual marching cubes and our post-processing.
Software tessellation on the GPU, developed by Curie and colleagues in 2019, looks something like this. Whoop, 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 whoop. Ah, stop it, you! Get over here! Now, no more jumping around. Get into the grid. To see how software tessellation with grids can make your GPU happy, come see us on Wednesday in SAL 3.
Geometry rendering sparse voxel trees can be equipped with a level of detail structure to reduce aliasing effects and noise during camera movement. However, the correctness of geometry rendered at lower levels of details depends on the direction it is viewed from. So we propose a novel encoder-decoder neural network architecture that derives view-dependent supersampling patterns to resolve wrongly shaded pixels due to level of detail. Since the network is trained on local geometry patches, it generalizes to arbitrary models and it is able to resolve errors that cannot be detected by screen-based supersampling approaches. Thank you.
We compress character motion using a neural network while preserving its content. We train a neural network so that it predicts from time to the character pose. We propose adaptive Fourier feature to reconstruct complex motions. The result of a method can compress motions with rich details like this. Our talk will be Wednesday, 11, so see you at the talk.
We introduce Neural MLS, a space-based deformation technique guided by a set of displaced control points. Neural MLS is built upon moving least squares, where the control point weighting function, which is traditionally based on inverse distance heuristics, is replaced with a neural network. By training a neural network, we can inject the underlying shape geometry into the deformation parameters and exploit the innate smoothness of neural networks. Come to our talk to hear more.
we present a novel interactive facial animation editing system that can express the naturalness of non-linear facial movements in real time. The proposed system is based on a fully automatic algorithm that maintains all positional constraints while deforming the facial mesh as realistic as possible. If you are interested in editing facial animation, please come to our talk. Thank you.
Recent work has proposed a domain decomposition approach for breaking down complex readability simulations with context into smaller partitions that may be solved in parallel. The approach reduces wall clock simulation time without sacrificing accuracy. However, for unstructured simulations, both is frequently form and break context. Therefore, an efficient algorithm must be used to traverse constraint graph and decompose simulation into smaller contiguous systems. We evaluate several efficient graph partitioning algorithms and even propose a new partitioning algorithm that outperforms the algorithm proposed in the previous work. Tired of blue zoom meetings or masks? Come and enjoy our colorful videos.
Are you tired of being two floating hands in virtual reality? We present a fast and easy to set up system to have accurate full body avatars in any virtual reality application. The user does a simple calibration step and the system handles the rest. Our avatars have accurate movements, time adjustment to the controllers, multiple mesh support, and collaboration.
We drop a ball on a wet sponge. The ball collides with and presses the sponge. With the pores compressed, fluid is ejected. For this, rigid body, elastic body, and fluid simulation must interact. We show how to mediate forces between the simulations, handling collisions, pore suction, and drag in real time. Come and hear the ultimate short paper talk.
If you were to edit a procedural model, you would need to tweak a set of sliders. It's too complicated and not cool. The alternative is to directly change the resulting 3D geometry, but you would lose the procedural representation. We present our paper about interactive editing of procedural models directly in the viewport. What you can see on the screen is an interactive editing session. Come listen to us on Thursday morning at 9 a.m. And yes, it's after the gala dinner.
Basically, our method is to create vector images using less dense meshes. Here's a nice example. On the left is a pair that we want. In the middle is the mesh created by our method. On the right is the mesh created by traditional method. Apparently, the mesh of traditional method is much more dense than that of our method, right? So let's begin our story.
Do your MPM simulations have numerical fracture? You could use the total Lagrangian formulation. But then, large deformations are hard to achieve, which were possible with Eulerian formulations for MPM. We present a method that achieves the best of both worlds. Our method can simulate large deformations while completely eliminating numerical fracture. To learn more, please come to our talk.
I'm doing this on behalf of the authors. It's expensive to simulate detailed fluids over a very large domain. So what the paper proposes is to couple any 3D fluid simulation with a 2D wave propagation method. That is called the equivalent sources method. And so this extends the 3D simulation over an arbitrarily large domain, and you can still zoom in and see all the great details.
Continuous collision detection is widely used in physical simulations. We explore CCD methods for triangle meshes whose vertices move along linear trajectories in a time step, and introduce the first exact root parity counter for CCD functions. Our method enables the efficient and robust simulation of closed meshes. Come to our talk for more details.
On Thursday, 10 a.m.
For the 20th anniversary of pre-computed radiance transfer, we introduce neural PRT. But what do a real-time technique from 2002 and neural rendering have in common? Our paper shows that there are many surprising links. If you'd like to find out how to get the most out of your neural renderer using insights from PRT literature, come see our talk.
Thursday morning. Thanks.
Physically based rendering of a scene from multiple viewpoints can be time consuming. So fortunately, path reuse method can be used to amortize the cost of tracing light paths. However, it remains unsolved for dense heterogeneous media. We hence address this problem with new path transformation and a novel variance reduction technique that overcome limitation of MIS. So our formulation reduces significantly the variance for rendering of multiple viewpoints at the same time. Come see us on Thursday morning.
Radiance field differentiation is a growing need for rendering in computer graphics. In our work, we derive an efficient differentiation algorithm to compute the gradient of the spherical harmonic basis function. We apply this to spatially differentiate the projection on spherical harmonics of the radiance field produced by spherical light. We demonstrate the usefulness of such differentiation for real-time rendering by computing the radiance field produced by spherical light and its spatial gradient on the sparse grid. Then, using an Hermite interpolation, the radiance field could be accurately interpolated and 18 points into the grid. Come to our presentation to satisfy your curiosity about the differentiation of spherical harmonics and to see other applications in rendering.
In this work, learning spectral unions of partial deformable 3D shapes, we explore the properties of the Laplace-Beltrami spectra. It is known that it encodes information about the shape geometry. However, it is not clear whether it is possible to perform spectral operations between different shapes. We show that it is indeed possible, taking the problem to combine two shapes. We show how to recover the full combined extrinsic geometry from the spectral partialities, or that it is possible to localize the union region on a template from those partialities. Learn more in the full presentation.
In this work, we present a simple yet effective formulation called coverage axis for shape scalation. Inspired by set cover problem, our method inherently introduces a compact and expressive approximation of the medial axis transform. Different from previous methods, coverage axis considers the problem from a global view and is able to handle generalized input, such as point clouds and poor quality meshes. Please check out the report and paper for more details. Thank you.
To create vector graphics of raster line drawings, we propose a vectorization method. Our method makes the output more accurate and reliable. To do so, our key observation is that the boundaries of the lines always provide reliable hints on similar line drawings that are difficult to distinguish using traditional thinning algorithms. Come to our talk and find out more.
Tractograms are a representation of the white matter architecture of the brain. They are composed of millions of 3D polylines. We propose a method to visualize in real time those billion segments, leveraging the latest mesh shader pipeline for an on-the-fly synthesis of the dataset based on a compressed representation, enabling interactions with massive tractograms. If you are interested by medical data, want to know more about the latest mesh shader pipeline, or even take some inspiration for your next fur rendering algorithm, come to our presentation.
We present Z2P, a fast neural technique for interactively visualizing raw point clouds as images. Z2P enables easy control of view direction, color, and light position, and produces surface visualizations instantly. Our solution doesn't require globally consistent normal orientation, and also avoids the issues of holes and overlaps encountered in traditional spotting techniques. Come to our talk to hear more.
We present a new framework for computing closed-space filling curves, namely cycles filling a surface. Without counting the initialization, the method is divided into two steps. The first one is the genetic algorithm optimizing Hamilton cycle in a given graph, decreasing, for example, the number of transitions between zones of different colors. The final step optimizes the geometry, including smoothness and even spacing. Additional objectives can be added, like anisotropy, and vector field alignment.
Did you know it's possible to fabricate surfaces flat that can automatically morph into a prescribed 3D geometry? It sounds like magic, but it's just physics. The fabrication technique is really simple. You just need to pre-stretch a piece of fabric and then use a 3D printer to deposit some plastic curves on it. When the fabric is released, it automatically pops into shape. Come see our talk on Friday morning to see how it's possible to find the optimal pattern to print to reproduce a given 3D surface.
Check out the boomerang we just designed. It's so perfect, and let's check it out in motion. Wow, so graceful. No worries, our method comes to the rescue. Our method can analyze the worst-case loads of assembly structure, suggest new parts for the user to add, and optimize the geometry to make the best boomerang ever. Come to our talk for more examples. Thank you.
Crowd simulation is about to get sketchy. Come and discover interaction field and directly sketch how you want people to behave towards you. Enter a world where the only limit is your own imagination. Designing new scenarios has never been that easy. Even a baby can do it. So come to our talk on Friday morning to discover interaction field.
Our method, spatio-directional mixture models, learns a single, joint distribution of the incoming radiance over the entire scene. This results in the directional distribution varying smoothly as we move through space. Using the same framework, we are also able to represent spatially varying BSDFs and ultimately perform product sampling. To learn more about our method, come to the session on rendering tomorrow morning at 9 a.m.
Thank you to all the speakers and the great presentations. I'm afraid we have to hurry up. So I will see you all in the city hall of the city of Reims, and I hope you enjoyed the day. Thank you.